deviation because it ties into what we're learning today. It builds on it. So remember, standard deviation means how far your data deviates from the mean. Mean is average of the data. So looking at this, for example, this data set, 1, 1, 1, 2, 3, 4, 6, 17. I found the mean, I added them up, divided by the total, right? Or you can use your calculator, right? Remember the one variable statistics, which gave me also the same thing, 4.4. So remember, mean is x bar notation. So our x bar was 4.4, which means the average of this data set was 4.4, and then our standard deviation was 5. So there's a standard deviation of 5 from the mean. So I just drew myself a little chart to remind you of what standard deviation looks like. So remember, all this data will fall within a certain number of standard deviations from the mean. So if my mean is 4.4, then I went one standard deviation above and below everybody. So I added 5 and got 9.4, I subtracted 5 and got this, okay? So I'm going to highlight in purple how many of these values fell within one standard deviation. Did one? Yep, one fell within one standard deviation. 2 did as well, right? Right within here. The one below, right? 3 fell within below, and then 4 fell within below, right? All of those fell within one standard deviation below, and then between 4.4 and 9.4, didn't 6 fall within one standard deviation. So isn't 17 my outlier? Because look, isn't that the one that fell within, oh, it took clear 2, it didn't fall within 2 standard deviations. 9.4 plus 5 was 14.4. 17 still wasn't within 2 standard deviations. So I had to go third standard deviation from the mean, 19.4. So 17 fell within the third standard deviation. Okay, sweet. So just statistically here, to get all the data, didn't we have to go 3 standard deviations? That outlier kind of made it a little bit skewampus, which is fine. Okay, so I want you to just note this because it's going to help make more sense today. There was 1, 2, 3, 4, 5, 6, 7 out of 8 values fell within one standard deviation of the mean. So what percentage fell within one standard deviation? Let's see. 7 divided by 8. 88% of the data fell within one standard deviation, so therefore, and then 0 fell within 2 standard. Well, okay, if I was to say this correctly, technically didn't 7 out of 8 fall within 2 standard deviations? Yeah, because they fell within 1, so they fell within 2. So then, within 3 standard deviations, finally, all of our data fell into place. Okay? But if I said what data was between 1 and 2 standard deviations, we'd say 0. Right? Between 1 and 2? Between 1 and 2 standard deviations. From 1 to 2, there was nothing, right? From this data set. Do you get what I'm saying? So 0 out of 8 fell in the 1 to 2 range of standard deviations. So the 0% fell from 1 to 2 standard deviations right in here. And then we have 1 out of 8 fall within 2 to 3 standard deviations. So then all of the data fell within 3 of those. Okay. All right. So today we're doing normal distributions, which actually has to do with standard deviations from the mean, but it's different. It's the same, but let's talk about it. Okay. So normal distributions. So first of all, many common statistics in the real world, such as human height, this is true, such as human height, weight, or blood pressure gathered from samples in the natural world, tend to have a normal distribution. And we'll talk about what that means. So once again, there's a lot of things in the world that have a normal distribution about their mean. So a normal distribution about their average. Okay, a normal distribution has data that vary randomly from the mean. So it has data that varies randomly from the mean. The graph of a normal distribution is a normal curve. So right here is a normal distribution. So what it is a normal distribution has a symmetric bell-shaped curve around its mean. Does everybody see how this has a symmetric bell-shaped curve around the average? Okay? So you'll want to write this down. So right here, this picture, you'll want to write it down. So if it has a normal distribution, this is the statistics of what happens. So if and only if it has a normal distribution, then 68% of the data will fall within one standard deviation. So I'll say that again. If it has a normal distribution, then 68% of the data will fall within one standard deviation from the mean. So that means 34% below and 34% above will fall within one standard deviation. That's only if it's normal shaped. Okay, so, does everybody understand? Right, here's the mean. This is one standard deviation above and one below. So 68%, if it's a normal distribution, will fall within one standard deviation of the mean. So we split it up evenly, so that's 34% of below and above. Then, statistically, what happens with the normal distribution is 95% of the data will fall within 2 standard deviations of the mean. So I'm going to go right here. So 2 standard deviations. Now, 95% of the data will fall within 2 standard deviations. So that means all of this is 95% from here to here. So that's why it's split into 13.5 and 13.5. Because let's think about it. Take 95. Subtract off 68, right? Because that was within 1. Are you guys following me so that this can make sense? So 95 minus 68%. That leaves me with 27% to be split within 2 standard deviations. So I divide that by 2 to split it evenly. That gives 13.5% above and below. So between 1 to 2 standard deviations below and 1 to 2 standard deviations above, 13.5% of the data will fall in that range. But total, 95% will fall within 2 standard deviations total. Does everybody understand that? Questions? Am I being clear? Okay. So then, the next statistic, if it's a normal distribution, 99.7% of the data will fall within 3 standard deviations of the mean. So this is out to my 3rd standard deviation. And almost all of the data, 99.7, will fall within 3 standard deviations of the mean. So, once again, how did we get 2.35% in the 2 to 3 range? In the 2 to 3 range? Well, you take we take 99.7, we subtract off the amount that fell within 1, so minus 68, and then minus 13.5 minus 13.5, that leaves me with 4.7. Does everybody understand what I'm saying? So if you divide that by 2, that gives you 2.35. So then they don't list it in here, but what leftovers do we have to go below 3 standard deviations? So if it doesn't fall within, which 99.7% of the data will fall within 3 standard deviations, what percent of the data will not? So let's think about it. Isn't there 100%? So 100% minus 99.7, because 99.7 go within 3 standard deviations. That's 0.3. So then divided by 2 is 0.15, right? So I always like to add that in there for my own personal, because you might use it. So that means that 0.15 fall above 3 standard deviations and 0.15 fall below 3 standard deviations. So I just like to have that for my own knowledge, because you might need that statistic. Okay? So this is the probability distribution. And this, it will tell you if it's normal distributed or not. And if it is normal distributed, then you can assume these things. 34% will fall within 1, above and below, and so on. Does everybody have this curve written down? Okay, so now you have to be able to fill it out, so we're going to practice that, and I'll show you how I think of filling one of these out myself, okay? There's many different ways to memorizing this. Some people, like I've had some of my students just memorize the 34, 13.5, 2.35, and 0.15. They fill in one side and then they fill in the other side evenly. Because normal distribution will be bell-shaped curved around the mean. Does that make sense? This is how I personally think it's easier to memorize. I just like memorizing, okay, 68, 95, 99.7, and then doing some math because to me it's easier to memorize those 3 things. But it's up to you. So this is what I do. If I say fill out a normal bell-shaped distribution so that you can use it, let's fill out what we just saw. We're just practicing now. Does everybody understand? So on the test you'll have to fill it out yourself. So I say, okay, I'm going to draw a line, a bell-shaped curve. Here's my mean, right? So then I'm going to go like this. So 1 standard deviation above and below. So I go off to the side and I say, I know 68% of the data fall within 1 standard deviation. So I've got to split that up evenly. So 68 divided by 2 is 34. So 34% fall right here and 34% fall right here. Comfortable with that? Then I say to myself, okay, I know statistically 95% fall within 2 standard deviations from the mean. So I've already taken up 68%. So I do 95 minus 68. That's 27. It's going to be split evenly, so divided by 2. That's 13.5. So right here, 13.5% will fall from 1 to 2 standard deviations below, and 13.5 will fall within 1 to 2 standard deviations above. And then I say, okay, and then statistically I know, because I've got it memorized, that 99.7% of the data will fall within 3 standard deviations. So I take 99.7 minus 95 minus, minus 95, right? That leaves us with 0.7 minus 95. So that leaves us with 4.7, right? Yep. Divided by 2 is 2.35. So I know that within 3 standard deviations, that's 2.35, 2.35. So I mean from 2 to 3 standard deviations. Okay, and then that leaves me with the leftovers of 100 minus 99.7. That's 0.3 divided by 2. I just like to put it in. So that's 0.15 and 0.15. So then I'm going to make sure I say, okay, that was 1 standard deviation from here to here, 2, 3, and then after 3. 1, 2, 3, and then after 3. Is everybody comfortable with that? Yes.
So on the 2.35, you can that up to 2.4.
No. Good question. It would be that exactly. Questions on that? Because if you rounded that, then this rounding would be off, right? Okay. So, here we go. So this is a probability distribution. If you're told it's a normal distribution, then you can assume, okay, so 34% will fall within 1 standard deviation and so on through this. Okay, so let's apply this now. Okay, so I just want you, so next thing. So sometimes data are not normally distributed. We've seen a lot of examples where this happens, but we haven't realized that we're looking at a non-normal distributed set of data. So a data set could have a distribution that is skewed. They call it skewed. So, which is an asymmetric curve in which one end stretches out further than the other end. So when a data set is skewed, the data do not vary predictably from the mean. So with a normal distribution, we can always predict things, right? But if it's skewed, you can't use normal distribution to make predictions because it's not going to have a common thing that happens. So this means that the data do not fall within the standard deviations of the mean like normally distributed data. So you couldn't take something skewed and apply this probability model. So it would be inappropriate to use mean and standard deviation to estimate percentages for skewed data. So this is an example of positively skewed. This is negatively skewed. So this is an example, guys. I just want to bring you back. You don't have to have a whole lot of, we don't have to spend a whole lot of like deep thought into this, but I just want you to kind of think about it. So does everybody see how this is normal because it's symmetric around the mean? Okay? And then we know the percentages that fall within these things. Now, negatively skewed and positively skewed are skewed to one side or the other. So I just want to bring you back to the first example we did today, reminding you of standard deviation and mean. So we did this, right? And didn't we decide that 88% of the data fell within 1 standard deviation, right? So that would not be normally distributed because we know in a normal distributed graph that 68% fall within 1 standard deviation. Does everybody understand? So there's non-normal distributed stuff. Does that make sense, everybody? Okay. So this one would be positively skewed because isn't there a lot more within 1 standard deviation? Are we all kind of comfortable with non versus yes, standard? Okay. Let's apply normal distribution. So looking at this picture here, pay very close attention because it tends to be confusing for people at first to see how to use this. So it says, the bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed. So we know they're normally distributed about the mean. And our mean's 115 kilograms, it says. Okay, so our average, our mean, and I'm going to write that down, our X bar is 115 kilograms. Sweet. So it says approximately what percentage of female brown bears weigh between 100 kilograms and 129 kilograms? So look over here. Does everybody see how over here, well, first of all, we have a bell-shaped curve, right? And then over here, we're given the percentages. Is everybody comfortable with that? Okay, sweet. So let's answer this question. Approximately what percent of female brown bears weigh between 100 kilograms to 129 kilograms? So down here is the weight in kilograms. So from 100 to 129, what intervals is that? This is 100 to 109, right? This is 110 to 119 kilograms, and then 100 to 129. Doesn't it stop right there? So now let's look. What percent of bears weigh between 100 to 109 kilograms? Well, let's see. Let's trace that straight across. Approximately, I'm going to kind of trace that across. We're looking over here, ding, 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 ding. Roughly 24-ish, right? Isn't this 5? 30? Does everybody see? So from here to here, there's 20, the percent is 24. Okay, so then let's look right here from 100 to 119. What percent are those? So we're adding these up. So what percent is that? So that's 42. I call that 42. And then 120 to 129. Same as over here, right? 24. So let's add those up, and we're done. So 42 plus 24 plus 24. So 90% weigh between 100 and 129 kilograms. Is everybody comfortable with that? Okay, so we've answered the question. Okay, so let's answer the next question. Same picture here. It says approximately what percentage of female brown bears in problem 1, which is what we just did, weigh less than 120 kilograms? So what percent weigh less than 120 kilograms? So I find 120, isn't this the starting point? So the ones that weigh less than that would be all of these, right? So let's add those up real quick. So we're using these percentages on the side here. So this one was 42, right? So we're doing 42 plus percent plus 24 plus, let's look right here, 5, right? Plus 5, and then maybe plus 1. Yep. So we're doing approximately. You got 72. Okay, sweet. So 72% weigh less than 120 kilograms. Okay. It says the standard deviation in the weights of the female brown bears is about 10 kilograms. Approximately what percent of female brown bears have weights that are within 1.5 standard deviations of the mean? So we've got to kind of think about this a little bit. So once again, the standard deviation is 10 kilograms. So it wasn't our mean. It was 115. Okay, so I'm going to draw standard deviations, how we've been practicing. I'm going to kind of give myself some room here. Okay, so we know that the average is 115, right? So let's go one above and one below so that we can look here. So what weight is one above? It says 10 kilograms, right? So 125. Sweet. One below? 105. Okay, now it's 1.5 standard deviation. So what's a half of a regular one? A whole full one's 10, right? So 5. So now we're going this would be 1.5, so that would be at 130. And then we're going 1.5 below, so that's 100, right? So now let's look at our picture. So between 100 to 130, boom to boom, right? So didn't we already get that? So that's within 1.5. This is 1.5 standard deviation. Oh, we only went because it said 1.5. So we didn't.
You meant from 25.
Oh, yeah. Sorry about that. Yes, so that would be 0.5 further than 1. Yes. Okay, so guys, what percent fall within 1.5 standard deviations? Didn't we do that in the first problem? Because it's on the same interval, right? So we said on problem number 1 that was 90%, right? So 90%. Sweet. Okay, so now here's my next question. I said 90%. Thank you. Did I write degrees over here?
Yeah, no.
Oh, okay.
You did it up top.
Good thing. Okay. So it says on C, if 3,000 bears, if we have 3,000 bears, how many can you expect to weigh between 100 to 129? Can we expect 90% of them? So out of 3,000 bears, how many bears? Let's calculate it. So 3,000 times 0.90, right? So how many brown bears exactly, or how many bears exactly can we expect? 2,700 bears. Does everybody understand how to do this? Okay, sweet. So do 1 through 4. You're going to be doing the exact same thing we just did here. You're using these percentages on the side. Okay, so now we know if we're given that it's normally distributed and asked to draw a graph, then we can go ahead and do that because it's pretty simple. It's pretty straightforward. As long as we know it's normally distributed, we know it's going to be a bell-shaped curve, right? Okay, so let's draw this. It says when data is normally distributed, you can sketch a graph, which is what I just said, using the fact that a normal curve has a symmetric bell-shaped curve. So sketch a normal curve for each distribution. Now, guys, this is a key word. If you see on the test, it says sketch a normal curve. That's when you say, oh, I'm sketching a bell-shaped curve. Does everybody understand the key word here? Okay, so let's go ahead and do that. It says, label the x values at 1, 2, and 3 standard deviations from the mean. Okay, sweet. So we're going to get specific. We're going to draw out our bell-shaped curve. Ding, ding. And then it says our mean is 45. So that would be right here, right? And then our standard deviation is 5. So let's go one above. One standard deviation above. So that would be 50. And let's go one below. 40. Let's go. So I'm going to label it. That's one standard deviation above and below. Let's go to 2 standard deviations. I'm going to try to give myself some room. So it would be at 55, right? That's 2. And then 35. That was 2. And then we're doing it to 3 standard deviations. So this would be 30, right? 3. And then 60. Good. So now 3. Now I'm not requiring you to put in percentages, but if I said to you, sweet, so what percent of bags can you expect to weigh between 35 to 40? It'd be 13.5%, right? Remember how you remember the percentages that work for normal bell-shaped curves. Do you understand what I'm saying? I'm not asking you that right now. I'm seeing if you can draw a graph, so that's all you're going to do. Okay, so one more really quick. It says, for a population of male European eels, the mean body length and 1 positive and negative standard deviations is shown below. Sketch a normal curve showing the eel lengths at 1, 2, and 3 standard deviations from the mean. So we're asked something a little bit differently, but let's see if it's pretty much the same thing. So the mean body length is this, right? So we know it's normally distributed, so I'm drawing my bell-shaped curve here. So our mean is 15.7, correct? Are we following me? Then it says 1 standard deviation. See this plus 1? That means 1 standard deviation above. This minus 1 means 1 standard deviation below. So it's saying the one above puts us at 18.5. So we're going to have to use that, and then the one below puts us at 12.9. So we've got to use that to figure out what is the standard deviations. Can we do that pretty quick? What would you do? Because if I need to draw it to 2 more standard deviations, what would we do?
Find out
2.8. How'd you get that? You're right. Oh, you're saying that when we add standard deviations and subtract, right? So you said, how did I get from 15.7 to 18.5? You take 18.5 minus 15.7, right? Well, that better be the same. 15.7 minus 12.9. You got 2.8? So to go to another standard deviation, we'd add another 2.8, right? Above and below, we'd subtract 2.8. And we'd keep going. I'm not going to keep going. We understand what we're doing?
Yeah.
Okay. Okay, so here's my next question, though. This is the important part. Okay, oh, well, maybe we should keep going for this question. Okay, let's quickly fill this in still. I wish I would have drawn this a little bit bigger. Okay, tell me what's this? So 1 standard deviation. We need this for the question, okay? Really quick. So what's my second?
21.3.
21.3, right? Okay, that was 1, 2. This is like not fitting very good. So what's my next one? I'm going to put it up here. Add another 2.8. So we have 3 standard deviations. Because this was our mean. There's 1 standard deviation. 24.1. Okay, let's do below. That was 2.
10.1.
10.1 and 1 more. Because that was 3. No, that was 1. That was 2, right?
7.3.
Okay. So wait. 1, 2. Okay. Gosh, I couldn't fit. I should have drawn this bigger. Okay, this is 7.3. That was our 3rd standard deviation, right? Okay. So the question is, out of 200 eels, how many would you expect to be less than 10.1 inches? So let's look here. Out of 200 eels, how many would you expect to be less than 10.1 inches? So isn't that past this? Below, and that was our 3rd standard deviation, right? So what's below 3 standard deviations? What percent? Good, 0.15, right? So 0.15. So let's take our 200 and times by 0.15. How many eels?
30.
30. 30 eels. Does everybody understand how to do it? And how to apply it? Okay. That's it. Finish the worksheet.